Polaris Spaceplanes secures €50 million contract with Germany's defense agency for revolutionary reusable launch system. Date, March 1, 2025. Time, 13:27. Executive Summary. On February 27, 2025, Polaris Spaceplanes, a burgeoning aerospace company based in Germany, announced the acquisition of a €50 million contract from the Federal Office of Bundeswehr Equipment Information Technology and In-Service Support (BAINBW). This contract is pivotal for the design of an innovative reusable hypersonic research vehicle aimed at both defense applications and scientific research. The project is set to advance hypersonic flight capabilities, establishing Polaris as a key player in the aerospace sector. Company overview. Founded in 2019, Polaris Spaceplanes has rapidly emerged as a leader in the development of advanced aerospace technologies. The company's primary focus has been on creating the Aurora, a versatile spaceplane designed for hypersonic transport. Prior to this contract, Polaris has engaged in several significant projects, including the development of demonstrators such as the Mira 2 and Mira 3 vehicles, which are critical to the testing and validation of their technological innovations. Details of the contract. The newly awarded contract entails the design of a two-stage fully reusable hypersonic vehicle which will serve dual purposes as a hypersonic testbed and a small satellite launch system. The hypersonic vehicle is expected to operate under a horizontal takeoff system, facilitating advanced experiments in high-speed flight aerodynamics and propulsion technology. The contract not only covers the design phase but also includes provisions for future manufacturing and flight testing of the full-scale hypersonic vehicle. This anticipated progression is expected to bolster Germany's capabilities in both defense and scientific research sectors. Technological significance. The hypersonic testbed is designed to push the boundaries of existing technologies, providing a platform for experimental research that is crucial for the development of next-generation aerospace systems. The vehicle will enable the exploration of high-speed flight, which has significant implications for both military applications and commercial space travel. Moreover, the secondary capability of the vehicle to launch small satellites enhances its utility, allowing for diverse applications in the rapidly growing satellite deployment market. By integrating an expendable upper stage, Polaris aims to position itself strategically within the evolving landscape of aerospace innovation. Background and previous engagements. The recent contract builds on Polaris's previous engagements with BAINBW, including a notable contract awarded in April 2023 for the development of a linear aerospike rocket engine, the AS-1. The successful test firing of this engine, utilized in the Mira 2 demonstrator, demonstrates Polaris's commitment to advancing hypersonic technology and its ability to deliver on complex aerospace projects. The continued collaboration with BAINBW signifies the trust and confidence that the German military places in Polaris's technological expertise, positioning the company for future growth and expansion within the aerospace sector. Industry impact. The implications of this contract extend beyond Polaris and BAINBW. It represents a significant step forward for Germany's defense capabilities and the broader European aerospace industry. As nations increasingly prioritize advanced aerospace technologies, Polaris's advancements in hypersonic systems could place Germany at the forefront of this critical area. The dual-use nature of the hypersonic vehicle, serving both military and scientific research purposes, could foster innovation in various fields including national security, telecommunications, and environmental monitoring, thereby contributing to a more robust aerospace ecosystem in Europe. Future prospects. With the design phase set to commence, Polaris Spaceplanes is optimistic about the future stages of the project, which may involve manufacturing and flight testing. The company anticipates that successful development and deployment of the hypersonic vehicle will not only enhance Germany's defense capabilities but also strengthen Polaris's position as a competitive entity in the global aerospace market. The ongoing advancements in hypersonic technology and the successful implementation of the Aurora project will likely attract further investments and partnerships, ultimately driving innovation and economic growth in the aerospace sector. Conclusion. The acquisition of this €15 million contract marks a significant milestone for Polaris Spaceplanes and underscores the growing importance of hypersonic technologies in modern aerospace applications. As the company embarks on this ambitious project, it not only aims to advance its technological capabilities but also to contribute to Germany's strategic objectives in defense and scientific exploration. The successful execution of this contract could redefine the landscape of aerospace innovation and establish Polaris as a leader in the field. The counterintuitive information in the content relates to the common perceptions surrounding hypersonic technology and its applications. While hypersonic vehicles are often viewed primarily through a military lens, the contract secured by Polaris Spaceplanes emphasizes a dual-purpose approach combining defense with significant scientific research capabilities. This highlights that advancements in military technology can also drive progress in civilian and scientific domains, countering the traditional narrative that separates military innovations from their potential peaceful applications. Another counterintuitive aspect is the notion of reusability in space launch systems. Many might assume that hypersonic vehicles would be single-use or disposable due to the extreme conditions they face. However, the focus on a fully reusable hypersonic vehicle challenges that assumption, suggesting that innovations in materials and design can allow for sustainable practices even in high-stakes aerospace environments. Furthermore, the integration of a small satellite launch capability into a hypersonic vehicle is unexpected. Typically, satellite launch systems are separate from hypersonic research vehicles, which might lead one to think these two functions would not converge. However, Polaris's design indicates a blending of capabilities that could streamline costs and enhance operational flexibility, thus reshaping expectations about what hypersonic vehicles can achieve. Lastly, Polaris Spaceplanes is a relatively new player in the aerospace sector. Founded in 2019, which raises questions about the feasibility of such ambitious projects being awarded to a company with limited historical precedent. This underscores a broader trend in the aerospace industry where newer companies are increasingly trusted to handle significant defense contracts, challenging the assumption that only established firms can lead in high-tech aerospace projects. The recent €50 million contract awarded to Polaris Spaceplanes by Germany's Federal Office of Bundeswehr Equipment, Information Technology and In-Service Support (BAINBW) is a noteworthy development in the aerospace sector, especially concerning hypersonic technology. While the contract's primary focus is on the design of a reusable hypersonic research vehicle, several details within the reports highlight crucial aspects that are often overlooked but carry significant implications for both the defense and commercial aerospace industries. 1. Dual role of the vehicle. One of the most important yet understated elements is the vehicle's dual role as both a hypersonic testbed and a small satellite launcher. Many reports emphasize its defense applications but downplay the scientific research capabilities. This dual functionality is significant for several reasons. Innovation in research. The vehicle will provide a platform for advanced experimental research in high-speed flight aerodynamics and propulsion technologies. This could lead to breakthroughs in aerospace engineering that extend beyond military applications, benefiting civilian space exploration and satellite deployment. Cost efficiency. Utilizing a single vehicle for multiple purposes can lead to cost savings in both development and operational phases. This efficiency could make hypersonic technology more accessible for various applications, thereby accelerating its integration into broader aerospace practices. Interoperability. The ability to switch between defense and commercial uses enhances the vehicle's value, potentially attracting a wider range of partnerships and investments in future projects as it opens avenues for collaboration between military and civilian sectors. 2. Importance of the design phase. While the contract is focused on the design of the vehicle, many observers may overlook the significance of this phase. The design process is critical for several reasons. Foundation for future developments. A thorough and innovative design phase is essential for the success of subsequent manufacturing and flight testing. If the design is not robust, it may lead to failures in later stages, which could waste resources and time. Advanced technology integration. The design phase allows for the integration of cutting-edge technologies that may not have been previously considered. This could include new materials, propulsion systems, or aerodynamics principles that enhance performance and safety. Regulatory compliance. Navigating the complexities of aerospace regulations requires careful planning during the design stage. Ensuring compliance can prevent costly modifications later and facilitate smoother transitions to testing and operational phases. 3. Previous engagements and technological progress. The contract is a continuation of Polaris's relationship with BAINBW, building on previous contracts including the development of the linear aerospike rocket engine. The reports highlight the successful test firing of this engine. But the implications of these successes extend beyond mere milestones. Track record of reliability. The successful test firing of the AS-1 engine enhances Polaris's credibility as a reliable partner in aerospace projects. This reliability is crucial for securing future contracts and ensuring continued investment in hypersonic technology. Feedback loop for innovation. The experiences gained from previous projects create a feedback loop that informs the design of the hypersonic research vehicle. Lessons learned from past successes and failures can lead to more informed decision-making in the current project, potentially improving outcomes. Accelerated development timeline. With a history of successful projects, Polaris may be able to expedite the design and development processes for the new vehicle. Their established knowledge base can reduce the learning curve often associated with new aerospace endeavors. 4. Strategic implications for Germany's defense. The contract is not just a business deal, it has strategic implications for Germany's defense capabilities. Enhancing national security. The development of advanced hypersonic technologies can significantly bolster Germany's defense posture, especially in the context of evolving threats. The ability to conduct rapid testing and deployment of hypersonic systems can provide a strategic advantage. Positioning within NATO. As a member of NATO, advancements in hypersonic capabilities contribute to collective defense strategies. Germany's investment in this technology could strengthen its position within the alliance, potentially fostering greater collaboration on defense initiatives involving hypersonic systems. Economic impact. The investment in hypersonic technology is likely to stimulate the German aerospace sector, creating jobs and fostering innovation. This economic impact may be understated in discussions focused solely on the military applications of the vehicle. 5. Future options for manufacturing and testing. The contract includes provisions for future options related to manufacturing and flight testing, which is often overshadowed by the initial design focus. Scalability. The inclusion of manufacturing and testing options indicates that Polaris is planning for scalability. This foresight is critical as it suggests that the company intends to transition smoothly from design to production, minimizing potential delays. Market readiness. By planning for testing and manufacturing from the outset, Polaris positions itself to rapidly bring the hypersonic vehicle to market. This readiness can be a competitive advantage in an industry where technological advancements are swift and often outpaced by bureaucratic processes. Feedback and iteration. The opportunity for flight testing allows for iterative improvements based on real-world performance data. This process is essential for refining the vehicle's design and operational capabilities, ensuring that it meets both defense and commercial needs effectively. Conclusion. The €50 million contract for Polaris Spaceplanes to design a reusable hypersonic research vehicle is a significant development that carries implications well beyond its immediate scope. The dual role of the vehicle, the critical nature of the design phase, the importance of previous technological engagements, the strategic implications for national defense, and the foresight in planning for manufacturing and testing are all crucial elements that deserve attention as the aerospace industry continues to evolve. Recognizing these often overlooked aspects will be essential for understanding the broader impacts of such contracts on innovation, national security, and economic growth. Polaris's advancements in hypersonic technology could not only redefine defense capabilities but also catalyze a new era of aerospace exploration and research. 1. Significance of the €50 million contract. The recent €50 million contract awarded to Polaris Spaceplanes by Germany's Federal Office of Bundeswehr Equipment Information Technology and In-Service Support BAINBW marks a pivotal moment for the company and the German aerospace sector. This contract not only signifies a substantial financial investment but also underscores the trust placed in Polaris's capabilities to deliver innovative aerospace solutions. The focus on the design of a reusable hypersonic research vehicle indicates a strategic alignment with Germany's defense modernization efforts and demonstrates the increasing importance of hypersonic technology in military and scientific applications. This contract, therefore, serves as a critical milestone for both Polaris and the broader German defense industry, highlighting the potential for future collaborations and advancements in aerospace technologies. 2. Dual role of the hypersonic vehicle. The development of a two-stage fully reusable hypersonic vehicle by Polaris is significant for its intended dual functionality. Primarily serving as a hypersonic testbed for defense-related experimental research, the vehicle can also function as a small satellite launcher when equipped with an expendable upper stage. This versatility enhances the vehicle's utility, allowing it to support advanced research in high-speed flight aerodynamics and propulsion technologies while also addressing commercial needs such as satellite deployment. This dual capability positions Polaris to tap into both defense contracts and commercial opportunities, potentially broadening its market reach and establishing it as a versatile player in the aerospace landscape. 3. Technological advancements and previous achievements. Polaris Spaceplanes has built a foundation for success through its previous projects, notably the development of the AS-1 linear aerospike rocket engine and the Mira-2 demonstrator. The successful test firing of the AS-1 engine and its in-flight ignition on the Mira-2 underscore Polaris's technological capabilities and experience in hypersonic technologies. The experience gained from these prior contracts not only enhances credibility with governmental agencies like BAINBW but also provides a robust platform for the development of the new hypersonic vehicle. This trajectory of progressive achievements illustrates how Polaris is leveraging its expertise to push the boundaries of aerospace technology in both defense and scientific research. 4. Future implications for the aerospace sector. The contract with BAINBW and the subsequent development of the hypersonic vehicle could have far-reaching implications for the aerospace sector, particularly in Europe. With increasing investments in hypersonic research and development, Polaris's initiatives could inspire similar projects across the continent, fostering innovation and collaboration within the European aerospace community. Additionally, as nations recognize the strategic importance of hypersonic capabilities, this contract could lead to enhanced defense capabilities not only for Germany but also for its allies, reshaping the dynamics of global aerospace and defense sectors. The successful realization of this project may position Polaris as a leader in hypersonic technology, influencing future trends and collaborations in the industry. 1. X-15 rocket plane program 1959–1968. The X-15 program, a joint effort by NASA and the U.S. Air Force, developed a rocket-powered aircraft capable of reaching the edge of space and achieving hypersonic speeds of over Mach 6. The aircraft was designed for a variety of purposes, including testing the limits of high-speed flight, gathering data on aerodynamics, and conducting scientific research. The X-15's innovative design and technology paved the way for future aerospace advancements, including the Space Shuttle program. 2. Space Shuttle Program 1981 to 2011. NASA's Space Shuttle program was a groundbreaking initiative focused on reusable spacecraft capable of carrying astronauts and payloads to low Earth orbit and back. The program emphasized the importance of reusability in space exploration, allowing for multiple missions with the same vehicle. The Space Shuttle served various purposes, including scientific research, satellite deployment, and the construction of the International Space Station (ISS). Its legacy continues to influence modern spaceflight designs and reusable launch systems. 3. Boeing X-37 2006 present. The Boeing X-37, an autonomous reusable spaceplane, was developed to test new technologies and conduct experiments in space without a crew. The X-37's missions have included testing orbital maneuvers and materials in the space environment. Its ability to land on a runway after completing its mission reflects the shift towards reusable space vehicles. Similar to the goals of Polaris spaceplanes with their hypersonic research vehicle, the X-37 program has contributed valuable data that supports both defense and scientific research objectives. The recent contract of €50 million secured by Polaris spaceplanes from Germany's defense agency marks a significant milestone in the aerospace industry, particularly regarding hypersonic technology. As the company embarks on the design of a revolutionary reusable hypersonic research vehicle, the future outlook for both Polaris and the broader aerospace sector is poised for transformative changes. Here are some predictions for the future based on current trends and developments. 1. Advancements in hypersonic technology. The development of the hypersonic research vehicle by Polaris will likely accelerate advancements in hypersonic flight technology. This vehicle, designed as a testbed for high-speed flight research, is expected to contribute valuable data that could enhance propulsion systems, aerodynamics, and materials science. The successful implementation of such technologies may lead to a new era of faster and more efficient air travel, as well as improved defense capabilities. 2. Increased investment in aerospace innovation. As nations recognize the strategic importance of hypersonic capabilities, investments in aerospace innovation are expected to surge. Governments akin to Germany's initiative will likely allocate more funding towards research and development in hypersonic technology, satellite launch systems, and reusable space vehicles. This trend may stimulate competition among global aerospace companies, fostering a climate of innovation and collaboration. 3. Dual-use applications. The dual role of the hypersonic vehicle as both a defense asset and a small satellite launcher suggests a growing trend towards dual-use technologies in aerospace. This could pave the way for more integrated systems that serve both military and commercial purposes. As countries seek to maximize their investments in defense technology, the ability to leverage these systems for scientific research and commercial satellite deployment will become increasingly valuable. 4. Enhanced global collaboration. The complexities of developing hypersonic technologies may drive international collaborations among aerospace companies and research institutions. Countries with established aerospace sectors may partner with emerging players to share knowledge, resources, and technology. Such collaborations can help accelerate the development cycle of hypersonic vehicles and related technologies, ultimately benefiting global aerospace progress. 5. Regulatory and safety frameworks. As hypersonic flights become more common, there will be an urgent need for comprehensive regulatory and safety frameworks. Governments and international organizations will need to establish guidelines for testing, operating, and integrating hypersonic vehicles into existing air traffic systems. These regulations will be crucial for ensuring public safety and managing the environmental impact of hypersonic travel. 6. Growth of the space economy. The anticipated success of Polaris's hypersonic vehicle could stimulate the growth of the burgeoning space economy. With the capacity to launch small satellites into orbit, the vehicle may attract commercial clients from various sectors, including telecommunications, Earth observation, and scientific research. This could lead to a diversification of the aerospace market with new players entering the field and offering innovative services. 7. Job creation and workforce development. The expansion of hypersonic technology development will likely result in job creation within the aerospace sector. As companies like Polaris ramp up their operations, they will require a skilled workforce, leading to increased demand for engineers, technicians, and researchers. Educational institutions may respond by enhancing their programs in aerospace engineering and related fields, ensuring a pipeline of talent for the industry. 8. Environmental considerations. As hypersonic technology advances, considerations regarding environmental impact will become paramount. The aerospace industry is under increasing scrutiny to reduce its carbon footprint, and the design of hypersonic vehicles will need to align with sustainable practices. Future developments may focus on using alternative fuels or energy-efficient designs to mitigate environmental concerns associated with high-speed flight. 9. Military applications and defense strategies. The capabilities offered by Polaris's hypersonic vehicle could significantly impact military strategies. Countries may leverage such technology for rapid response capabilities, intelligence gathering, and deterrence. The integration of hypersonic systems into defense arsenals may alter global security dynamics, prompting nations to reassess their military strategies and alliances. 10. Public interest and support for space exploration. The advancements in hypersonic technology and the potential for space travel may rekindle public interest in space exploration. Successful tests and missions could inspire a new generation of scientists, engineers, and space enthusiasts. Increased public support may lead to further funding for space exploration initiatives, including missions to the Moon, Mars, and beyond. Conclusion. Polaris Spaceplanes' contract with Germany's defense agency is more than just a financial milestone. It represents a pivotal moment in the evolution of hypersonic technology and aerospace innovation. The future is expected to be marked by rapid advancements, increased investment, and a collaborative spirit across the globe. With a focus on sustainability, dual-use applications, and enhanced safety regulations, the aerospace sector is set to undergo a transformation that could redefine the boundaries of air and space travel. As Polaris and its counterparts push the envelope of what is possible, the world may be on the brink of a new aerospace revolution.